Okay. We should be live now. Okay. YouTube's working now. Twitch is working. Interesting. I swapped the order that the Nginx server is pushing out to YouTube and Twitch, because I had Twitch first and then I had YouTube, but YouTube wasn't getting signal and Twitch said it was too high. So I wonder if I swap them, if it's like, if it actually executes it in that order and it doesn't like send it out simultaneously or like copy it or something. Because if that's true, then I might just swap those and then keep dropping the bitrate till both of them are happy. Or at least until Twitch is happy, because Twitch should just eat whatever YouTube doesn't eat, I think. Or at least it's my theory. Okay, so then we're going to close this and close you. All right. This is gonna be a bit weird. This weekend I downloaded Linux because I wanted to kind of mess with it, see what all the fuss was about, and I kind of get it. I'm not gonna lie. It is so fucking nice compared to Windows, because I've been kind of getting more and more annoyed with Windows as I keep existing on the internet, and it is really minimal, and I really like that. But, and here's the most important part that I just did not anticipate. Shit just runs faster. I downloaded Dota 2 in like 8 minutes. That's not normal. Normally it takes my exact same computer like 30 to 40. It's still through Steam and everything, and it was just so much faster. And then Unity, you guys remember how long it takes that fucking white bar to refresh whenever I'm trying to like compile code. If I hop in here and I fucked it up, hold on. If I can hop in here and I do a quick edit like blah 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 blah, and I exit out and I save and I alt tab back in, just done. That's like 5 to 10x, I feel like, the speed that the old one used to be. I feel like that old one used to be so fucking slow. Okay, let me pop out the YouTube chat real quick. And then we're gonna pop out the activity feed. And then we can get a quad layout going on, hopefully. Okay, so we're gonna drag you down there. Oh, interesting. The noise is a little annoying, but you don't have to like it doesn't do like the Windows quad thing. You can just start dragging them into a corner without over. Oh, that's interesting. There's not that big pop-up thing. Okay. So, because of that, a lot of our features are minimized. It took me way too long to figure out how the fuck to set up this Nginx server. So that was a thing. And then, we currently do not have... I need to my drawing tablet that I just got, I need to actually probably redo the drivers for it into Linux. So that's currently out of commission right now. So we don't have Paint. And we also... I don't exactly know what Notepad is in this, because I typed in notes and I got like a weird sticky note thing and it was laggy as fuck and I hated it, so I'm probably never going to touch that app again. So, but here we are. So today is just going to be code. We're just going to be fucking with the code. Also, I hope that we don't run into any issues with like alt tabbing, because the screen dimensions are different. So what I was using previously to like keep track of when I'm in Unity versus when I'm in Writer is gone. So now what we're relying on is just which one's in focus. So hopefully that'll be fine. But it means if I need to make sure that if I'm hovering over an app that I also click into it so that you guys can see what the fuck is happening. But other than that, I think we're ready to keep coding. Oh, let me pull up, before I forget, before I wiped my drive, hold on. Hold 1 second. Okay. Before I wiped my drive, I was doing something. Oh, I downloaded all my files that I wanted to keep. One of those was my backups, or my PC backup that had the notepad of what we're doing next. So let me hop over to that. My stream visible notepad. Well, I just realized, I guess it didn't save. Cool. The instructions we wrote last stream are gone. So let me let me hop back into here, and I was gonna pull up the last stream, and then I can see what was the list of things we did, because I don't feel like remembering. There was like 6 or 7 things that I kept adding to the list, and I know I'm going to forget if I try to do this. View my channel, live, mute so I don't have to hear myself talk. Okay, somewhere around here. God damn, at what point did I have this notepad up? I think whenever I bring it back, I think I'm going to want it to have way more contrast, because holy shit, trying to see it on the side is way more of a bitch than I thought it was. Or at least when I'm scrolling through here. It might be easier whenever you're, you know, actually looking at it in the stream, hopefully. Okay. Here we go. Alright, I got the list. Let's put this into something. Hold on, there's got to be a way to do the text doc. How to do Notepad in Linux. Low Linux Mint was what we're using. Use something called text editor. Oh, okay, here we go. So let me go into here, and then let me pull up that, oh fuck, I forgot to pause. No, the list is not here. 1 second, back up. Okay, so tie actions to visuals. On spawn, create a prefab and attach it to the visual data. Set up camera. Make the walls higher to match 3D. Over the shoulder, so check occlusion. Make sure turn system works again. And oh yeah, enemies slower than the player currently can't act. So we gotta fix that. Alrighty, that's our to-do list. Let me figure out how to sort of pop this out. Oh, while we're doing this, let me write down the command that I needed to start the Nginx server, because figuring out that exe, or that there's not an exe was a scary moment. Okay, Let me put that down there at the bottom. I don't think there's any security issue with writing this here, because it's just the command to restart. Yeah, that should be fine. All right, let me go into OBS, and there's got to be a way to make this look more or easier to stand out, or maybe it will when I put it in here. Window capture. Let's put stream visible notepad. Okay, well, it immediately found the right document, so that's cool. Let's put that over there. And let's crop out the menu at the top, because I don't think we'll need that for anything. I actually don't know how to crop on this. Uh-oh. Fuck. I just moved OBS and it's now above my it's now above my monitor. So I don't know how I'm going to pull it back down. So I guess we're just gonna leave that for now. I'll deal with that at a different time. Let's get to work, because you should be able to see it at least, and that's all that matters. Okay, so tie actions to visuals. Yeah, so that's the first big thing. We need to make it such that when an agent completes an action, that the visual has a cue for it, and that the visual can pop that cue based on the agent, and then we're set. So what I was working on off stream is setting up a let's go into streaming assets. What the fuck is this file? Default asset. There's a resource, hold on. In the resources folder, there was a JSON. Is that what that is? It is what that is. Okay, that's weird. So yeah, I need to figure out how to make an asset bundle that I can then bundle the meshes into and then store those, I think. So that's one route. The other route is I make, which I think would be better. The other route is I have to make a prefab per enemy type. But I'd rather not do that. We better just load one prefab, slot in the mesh, and then play the animation on it. So, let's pull up. Close this. Like, sorry. Those are those three, and then we have this. Okay. Let's make a new tab. I don't think I have a way now, because it's OBS is now no longer in frame fully. It's like half there, so I can like disable and re-enable stuff, but the top is missing. Maybe I can add the Chrome tab. Let's see. Or in this case, Firefox now. Okay, it's one of these. Is it this one? Yeah, it is this one. Okay. Mozilla Firefox. Let's disable the stream visible notepad for now. If I need to show it off, I'll try to remember, but you don't need to see my reference all the time. Oh, and then maybe if I full screen this, it'll be, oh god. Okay. don't know why the snap is throwing it off. I hate that. Okay. Fuck it. This is fine. Okay. So what did we... we were going to look up... Oh, yeah. How to create a streaming asset Unity. Or not streaming asset. What is this called? A asset bundle. The addressables package. Okay, let's see that package. Window, package management, package manager. Addressables. Okay. What is this? Addressables for Android? No, I don't care about that. Okay. Use window asset management addressables. Click the create button above to simply drag an asset into this window to start using addressables. Before you decide how you want to manage assets, refer to how addressables interact with your project assets. When you include a scene in your project build settings and build a player, Unity includes that scene and any assets used in that scene in your application's built-in data. Similarly, Unity includes any assets in your project resource folder in a separate built-in collection of assets. The difference is that assets in a scene are only loaded as part of a scene, whereas assets resources can be loaded independently. Addressable assets can be built either into your application as an additional set of local assets, or keep external to the build as remote assets hosted in a server and downloaded whenever they're needed. You can update remote assets independently from the application itself, although remote assets can't include code, so you can only change assets and serialize data. Okay, so I think this is correct. I want to be able to store JSONs and store models independent of the build, because that's not actually directly impacting the build. And then I want to be able to load those in on top of the data that's running the game. So I think this is correct. Okay. Installed by the player. Streaming assets folder. Okay, but does the streaming assets folder also not have to be in scene? Or do I have to put everything in resources? This will have to tell me, right? Addressable assets can either be built into your application as an additional set of local assets, or kept external to the build as... Okay. You can't update remote assets independently from the application itself. Oh, you can. Oh, although they be... Oh, I already read this. Okay. If you use the same asset both in a scene and a resources folder, then Unity makes a copy of the asset when building rather than sharing a single instance. For example, if you use a material in a built-in scene and you also use it in a prefab located in a resources folder, you end up with 2 copies of the material in your build, even if the material itself isn't in the resources folder. If you then mark that same material as addressable, you end up with 3 copies. Files with the system streaming assets can never be referenced by assets outside that folder. When you use addressables in a project, it's best practice to move any scenes and data in the resources folder into addressable groups and manage them as addressables. The build settings scene list must contain at least 1 scene. You can create a minimal scene that initializes your application. Okay. A small amount of data in resources folder typically doesn't cause performance issues. If you use third-party packages that place assets there, you don't need to move them unless they cause problems. Addressable assets can't be stored in resource folders. Okay. Unity partially determines what to include in a content build based on how your assets and scripts reference each other. Sub-object references make the process more complicated. If an asset reference points to a sub-object of an asset that's addressable, Unity builds the entire object into the asset bundle in build time. That makes sense. If the asset reference points to an addressable object such as a game object, scriptable object, or scene, which directly references a sub-object, Unity only builds the sub-object into the bundle as an implicit dependency. Okay, makes sense. When you add an asset to the addressables group, the asset is packed into an asset bundle when you make a content build. In this case, the asset is explicitly excluded in the bundle, which is called an explicit asset. If an asset references other assets, then the referenced asset aren't dependencies of the original asset. This is called asset dependency. For example, if the asset is placed into asset bundle A, and the referenced assets are packed into asset bundle B, then bundle B is so if I made one bundle for meshes, one bundle for JSONs, one bundle for animations, and then I made one larger bundle called, I don't know, Steam Build 37, then those would become a dependency of, then Steam 37 is a dependency of those bundles. Okay, I understand. Yeah, okay. If more than one addressable reference is the same implicit asset, then copies of the implicit asset are issued in each bundle containing a referenceable addressable. So if we have prefab X and prefab Y, and both reference material P, then it's copied. When an implicit asset is included in more than one bundle, multiple instances of that asset can be instantiated at runtime rather than a single instance that your game logic expects. If you change the instance state at runtime, only the object from the same bundle can detect the change because all the other assets now have their own individual instances rather than sharing the common one. To stop this duplication, you can make the implicit assets an addressable asset and include it in one of the existing bundles or add it to a different bundle. Okay, so if I have two enemies that share the same weapon material on their swords, and I don't make that its own bundle, then they'll each make a copy of that asset, which isn't inherently bad. However, if then I want to modify all swords to glow red in runtime, I would have to do that for each prefab. Okay. I'm glad I read the docs, okay? Refer to memory implications of loading ooh. Speaking my language. Okay. Build content introduction. Okay. Or no, you're going back to get started. A key feature of the addressable system is that you assign addresses to your assets and use those addresses to load them into runtime. The addressables resource manager looks up the address in the catalog to find out where the asset is stored. Assets can be built into your application, cached locally, or hosted remotely. The resource manager loads the asset in any dependencies, downloading the content first if necessary. Because an address isn't tied to the physical location of the asset, you have several options to manage and optimize your assets, both in the Unity editor and at runtime. Catalogs map addresses to physical locations. Okay, so you can add like a directory, or when I say directory, I mean like a hotel directory, or like an index or something, I guess is what I mean more so. Because an address isn't tied to the physical. Okay. Although it's best practice to assign unique addresses to your assets, an asset address doesn't have to be unique. You can assign the same address string to more than one asset when useful. For example, if you have variants of an asset, you can assign them the same address to all the variants and use labels to distinguish between the variants. Huh. Well, that seems super useful. Why would that not be best practice? Like, imagine if I have 5 versions of a zombie, depending upon which particular world that you enter with zombies, and I can just label each one according to the world that you would go to enter to pull that specific prefab. That sounds incredibly useful. The addressables API method that only loads a single asset, such as load asset async, loads the first instance found if you call them with an address assigned to multiple assets. Other methods, like load assets async, loads multiple and then loads all the assets with the specified address. Does it include the label, or does it just grab the first one in the list? You can use the merge mode parameter of load assets async to load the intersection of 2 keys. In the earlier example, you can specify the address and the label, and the intersection is the merge mode to load asset 1. You can then change the label value to SD to load asset 2. For more information on how to assign addresses to assets, refer to making an asset addressable. For information on load assets by key, refer to loading assets. Okay. An asset reference is a type that you can set to any kind of addressable asset. Unity doesn't automatically load the asset assigned to the reference, so you have more control over when to load and unload it. Use fields of type asset reference and a mono behavior or scriptable object to specify which addressable asset to use for that field, instead of using the string that specifies the address. Use fields of type asset reference and mono behavior or scriptable object to specify which addressable asset to use for that field. Oh, okay. Addressables also provide more specialized types, such as asset reference game object and asset reference texture. You can use these specialized subclasses to prevent the possibility of assigning the wrong asset type to an asset reference field. You can also use the asset reference UI label restriction attribute, that's a mouthful, to limit assignment to assets with specific labels. Oh, wait, that sounds based as fuck. So I can be like, so imagine if I have a texture and that texture is only supposed to show up in one particular dungeon, then I can make a version of that texture with that label, and then when I go to do it, not only can I specify, hey, I want to make sure that I load that label, but you can also assess that, or what's the coding term I'm looking for here? The verify bool check. Assert. God, you can also assert that it's the right texture by making sure there's a restriction to remove all but a certain label on the asset. So yeah, if you have like let's imagine that. Oh, that's so useful. Okay, so let's imagine that, which is what we're going to do, is we're going to make a different algorithm for the mapgen of each region. Now, I can look at that and say, hey, we're going to load the textures for this region, and I can just make sure to limit all but this specific label on the loading of those textures. And so if it doesn't have that texture label, then it's not allowed to be loaded. That's huge. That's really nice. I like that a lot. Okay, to load an addressable asset, you can use its address or other key, such as label or asset reference. You can use its address or other keys, such as, okay, yeah. Refer to loading addressable units for more information. You only need to load the main asset and addressable loads any dependent assets automatically. Okay, when your application no longer needs to access an addressable asset at runtime, you must release it so that addressables can free the associated memory. The addressable system keeps a reference count of loaded assets and doesn't unload an asset unless the reference count returns to 0. As such, you don't need to keep track of whether an asset or its dependencies are still in use. You only need to make sure that any time you explicitly load an asset, you release it when your application no longer needs that instance. Huh. I don't know if I need this one as much, because, I mean, I guess it could be the case that I'll end up with a ton of models and I need to reduce that. I would assume that if they're still in map, though, that I don't release them because they're being used. Unless releasing is just like deloading the file, but the thing is still loaded, like it's already been loaded into scene. This is like keeping it referenced, basically. Maybe. I'm not sure. Let's see. Use addressable groups to organize your content. All addressable assets belong to a group. If you don't explicitly assign an asset to a group, addressables add it to the default group. You can use the group settings to specify how the build system packages the assets in a group into bundles. For example, you can choose whether to pack all the assets into a group together or into a single asset bundle file. Use labels to tag content that you want to treat in the same way. For example, if you had labels defined for red, hat, and feather, you can load all red hats with feathers in a single operation. Okay, I'm starting to feel bullshit. This sounds I guess it's not that crazy, because it's just gonna be like, have the tag, and it's gonna check the tags and load the thing. But to do that efficiently, maybe it's not too bad. This sounds like basically that if you're using Unity and you're not using this, you're kind of fucking up, though. Because this sounds incredibly useful. I don't know why you would never not need this for any project longer than a few months. We're still in the overview. Holy shit. To load an addressable asset, you can load, where were we? Groups and labels. Whether they're part of the same asset bundle or not. That's the crazy part to me. You can also use labels to decide how assets in a group are packed into bundles. Add an asset to a group and move assets between groups using the addressables group window. You can also assign labels. Oh, that's this one. I just realized you can't see what I'm looking at. The window that I managed to pull up was the addressable groups window. Okay, the schema to a group to define the settings used to build the asset in a group. Different schemas can define different groups of settings. For example, one standard schema defines the settings for how to pack and compress your assets. Another standard schema decides which of the categories can change post-release and cannot change post-release. I wonder what that means. That sounds scary. The addressable system produces a content catalog file that matches the addresses of your assets to their physical locations. It can also create a hash file containing the hash of the catalog. If you're hosting your addressable assets remotely, the system uses the hash file to determine if the content catalog has changed and needs to download it. Refer to content catalogs for more information. Oh. The addressable system separates the building of addressable content from the build of your player. A content build produces the content catalog, catalog hash, and asset bundles containing your assets. Because asset formats are platform specific, you must pick a content build for each platform before building a player. Okay. When you run your game or application in play mode, it can be inconvenient and slow to always perform a content build before pressing the play button. True. At the same time, you want to be able to run your game in a state as close to build player as possible. Addressables provide 3 options that decide how the addressable system loads and unloads assets in play mode. Use the asset database, loads assets directly from the asset database. The option typically provides a fast iteration speed for making both code and asset changes, but also least resembles a production build. Addressables load content from your last content build. Huh. Install addressables, we did that. Configure a project to use addressables. Although you can integrate addressables anytime, it's best practice to start it immediately and avoid unnecessary code refactoring and content planning changes later in development. Content built using addressables only references other assets built in that addressables build. Content that's used for reference to which is included with both addressables and the player build through the scene data and resource world is duplicated onto. To convert your project to addressables, you need to perform different steps depending on how your current project references and loads assets. Prefabs. Assets you create using game object components and save outside a scene. For information on how to upgrade prefab data to addressables, you prefer to convert prefabs. Assets you package in asset bundles and load with the asset bundle API. For information on how to do that, refer to convert asset bundles. Files your place is in the streaming assets folder. Okay, convert scene data. Okay, let's do this real quick. I'm gonna disable the internet one so that you guys can see what I'm doing in Unity, and I'll just have that on the side as reference. Okay, so I need to go into scenes, and I need to make a new scene. And this scene just loads the addressables. So we're gonna create a scene. We're gonna name this initialization, or initializer. And then we'll go into build settings, and we're going to add the initializer. We're going to remove that one. Then we're going to close it. So now test, which is the one we're actually using, it's completely independent of that. Select each scene in the project list and enable the addressable option in its inspector window. Okay, let's create this can be in default. I think that's fine because that's just that's our test scene, and then I'm probably going to replace it with like the run scene, which is just going to be loaded every time you do a new run. So that should be fine. Adds the initialization scene to the scene list. Removes it. Okay, select each scene, or do you also want to do the initializer? To convert a scene data to addressable, move the scenes out of the build settings list and make those scenes addressable. I guess it isn't addressable because it's loading the addressables. So that one isn't, but these are. Okay. Oh, and here are the tags that I can add. What the fuck is happening? Manage labels. Addressable labels. Wait, if I add like crypt as a region, can I just, oh my god, they're checkboxes. That's what it meant. That's insane. Okay, there's a lot of potential here that I am liking. This feels like it's gonna make loading assets and like swapping shit out once like builds start happening so much easier. Okay, so then what we're gonna do is Okay. So update the code used to load scenes to use the addressables. Okay, I'm not currently loading scenes, so we're fine on that. You can now split your one large addressable scene group into multiple groups. Well, currently it's just the one file, so I think we're okay. To convert a prefab into an addressable asset, enable the addressables option in its inspector window or drag it into the group. Okay, so this is default. I want to make a new group. How do I make a new group? You know what? Maybe we'll come back to that. Is it a group if I... Okay, it acted like it was a group, even though it didn't call it a group. Okay, convert asset bundles. Oh no, where was it? Hold on. Convert prefabs. Okay, so just tick this on. So let's go into prefabs. We're gonna have our tile prefab. Bam, addressable. Bam, addressable. Okay. So now if we rename this one to prefabs, can I then swap these over to the prefab group? Okay. If your project loads assets in their resource folders, you can migrate those assets to the addressable system. Manage to make the... To do this, enable the addressable option in each asset's inspector window. Okay, hold on. Let's make a new group, and we're going to name this... what would you call this? JSON configs. Then we'll go into resources, grab you, make it addressable. Any assets and resources that you wish to mark as addressable must be moved within the project. Are you sure when to proceed? Yes? Okay, so now we're in resources underscore moved. Okay. We're going to change that to JSON configs. So do I not put anything in the resource? Okay. Change the runtime code that's loading using the asset resources API to load them with the addressables API. Add code to release loaded assets when no longer needed. As with scenes, if you keep all the former resource assets in one group, loading and memory performance should be equivalent. When you mark an asset in your resources folder as addressable, the system automatically moves the asset to a new folder in your project name resources moved. The default address for a moved asset is the old path, omitting the folder name. So from resources.loadasync to addressables.loadasync. Okay. Wait, so this is, hold on, let's go back. This is incredibly easy then. If I hop into year and I go, oh yeah, I made it bigger hopefully so that it's easier for you guys to read. We're going to go into system scripts systems, run generation system, and we're going to change initialize VSD to, oh no, there it is. I see it. Addressables. Does it not have a load? Cannot convert source type. Yeah, because it's async. Is there not a non-async load for this? You might have to implement some functionality of the resource class differently after modifying your project to the addressable system. For example, consider the resource.load all. Okay, what about resources.load? How do we not have a non-async load? I guess it's fine right now because this technically doesn't work because there's not a mesh in the resources folder right now. So, but they were going to be in the streaming assets. Okay, hold on, let me go back to the docs. There has to be a way. There has to be a way to load this. It's like not async. We'll keep reading, I guess. Convert asset bundles, don't have any of those yet. To use an asset reference, add an asset reference field to a modify your resourceable object. After you create an object of that type, you can assign an asset to it in your thing. Unity doesn't load or release the reference asset automatically. You must load and release the asset after your Stressables API. Public asset reference. Handle is equal to load asset async on game object. Handle.completed. Alrighty, so I guess that means that we're gonna need to go, we can at least practice in our, where is it? Let's going to be under system data authoring. This game object will now need to be a asset reference. And then wake, we're gonna set, wait, how do you do this with, does this work with ECS? Because how do I bake something ahead of time? Unity ECS addressables. Fuck. Okay, we're not using addressables. Welp. Hold on. Whoops. Remove addressables. This never happened. Okay. So then we should undo that. Okay, close that one. Undo that. Close that one. Actually, no, I'll leave that open still. Okay, and then okay, I'm going to turn off burst for now, so that's fine. And then we're going to head into content management. For applications built with entity packages, unit assets, stores, and scenes, and other objects, content archives. Unity builds these content archives automatically during the player build process and loads uses. The other content management systems like heat, resources, asset bundles, and addressables don't work with entities or are suboptimal solutions for data-oriented applications. Okay. During the player build process, Unity generates content archives to store every object reference in the subscenes included in the build. Unity generates at least one content archive per subscene that references objects. If multiple objects reference the same object, Unity moves into a shared content archive where you can reference objects in the following ways. Strong reference, when you deliberately assign an object to a mono-behavior component in a subscene. Weak reference, when you type an object's untyped weak reference ID to an ECS during the baking process. Okay, let's go up to 1.3. Let's see what's currently happening. I think this is only for baked things. So I think for the other stuff, we'll still use the resources folder. Unless there's a really good reason to. Okay. Well, never mind that. Let's go back to asset bundles. Okay, I'm gonna be honest, this sounds a bit much for now. I'm probably just going to do resources.load until it becomes an issue, and then when it comes to an issue, I'll be like, man, I really should have done this earlier, but it doesn't feel like something I need to do right now, and I would rather kind of just keep the game flowing until I hate myself. So we're gonna do that. Let's go back to my checklist. All right, let's disable the internet showing. go back to the checklist. Okay, so the next thing was tie actions to visuals. Okay, right. So when we have, let me pull up systems or data, system data, or visual data. Throw it over here. Okay. I don't know why I made this agent particles. Why is it called agent particles if it's an action ID? Oh, that's right. I was writing ahead of time, like a dumbass. I'm deleting that just for my own lack of confusion. Okay. I was like, well, at some point, we'll probably need something that has a particle that's not referenced in the animation, and I'm going to need something to hold that, and I should write that right fucking now. Like, that's the most important thing. Okay. We're going to hop back over here, and we're going to delete you and delete you. Say it again. Oh my god, it's also... It's reloading it while I'm... Uni on the left is reloading it as I'm saving the script instead of having to wait for me to all tab back into it. That's nice. Okay. So... Let me pull up behavior system data real quick. I think if I remember correctly... I actually don't exactly know how we're going to get to where we're going right now, so I'm kind of constructing the mental model, and I feel like that's the least interesting part of, but also the slowest and makes me look dumbest part of programming. So it's the part I like streaming the least, but I figure I'll give it a shot and see how that goes. Where it's just me bashing my head against the wall looking like a dumbass, being like, I think I can do this, but how? And there's some programmer who's watching me losing this fucking shit, like, yes, just do this, there's an answer. Okay, so we have a queue of actions, and we got a queue of actions, and then we have another queue of actions that we're willing to create once we complete the action to store it and then have the visual system visualize it. So let's see. We need access to behavior system data when visual data goes to do what it needs to do, because it needs to reference the agent in question. It only has the ID number of the agent tied to the model. So we'll need to figure out which archetype it is, you know, which enemy it is. Oh, I need to play this set of animations or something like that. I could theoretically make a struct that's independent of this, that contains like the archetype ID, the animation set, etc. And I'll probably have to anyways. But actually, let's look up how do you do that in Unity. Most of the time when I've ever done like animations, it's always been like really shitty, just like, oh, we're going to make animations, quote unquote, and it was always just like a little prototype meme, like the object disappears or something like that. Like, it was always like really shitty shit. I don't know how you'd actually implement real animations into this equation and then save those, because that's probably going to dictate how I conceptualize this. Animations, Unity. Give me the docs. Animation. An animation system provides tools and processes to animate the properties of models and assets. For example, use an animation system to animate transform properties to move and rotate a model, or animate the intensity property to dim a light. Oh, that's interesting. Common tools include importers that import animations and models, editors that create and modify animation, and real-time animation state machines that determine which animation plays and when. Some animation systems also include specialized tools that define a human model and retarget animations between models with the same definition. Unity has two animation systems with different capabilities and performance characteristics: the Mechanim animation system and the Legacy animation system. Well, I'm never using the Legacy system, so what's the Mechanim? The Mechanim is based on animation clips. An animation clip contains information about how a character or game object changes position, rotation, or other properties over time. Think of each animation clip as a recording. An animation clip from an external source is created by an artist or animator with a third-party software, such as Autodesk, Max, or Maya. You can organize many animation clips into a structured flowcharts-like system called an animator controller. The AC also acts as a state machine, which keeps track of the animation clips being played on the criteria from the next animation clip should be played. For example, an AC might contain a single animation clip for a collectible item that spins and bounces. An AC for a door might contain two animation clips, one for the door opening and a second for the door closing. A more advanced might contain a dozen humanoid animations for each of the character's actions, such as idling, turning, walking, and jogging. The animation character might use blend trees to blend between multiple animation clips and provide fluid motion as the player moves around the scene. The Mechanim animation system all provides special features for handling humanoid characters, including the ability to retarget animation from one source to another and adjust muscle definitions to ensure the character deforms correctly. Is that like if you have two characters with different skeletons? Yeah, to different character models based. For example, you can retarget animations from a third-party animation library to your own character, then adjust the range of motion. These special features are available through Unity's Avatar system, which maps humanoid characters to a common internal format. The animation clips, animator controller, and avatar are connected together for a game object with the AC component. This component references an AC and, if required, an avatar for the model. The AC also references its animation clips. So we're probably going to have an AC per enemy, aren't we? And then load that in and then tweak it. There was one video I watched back in the day. Hold on, let me find this link. Because that was such a good video, and I kind of want to see if I could implement that as well, because that would be probably easier for my dumbass trying to do bad art. This would be under... I think I saved this in my... one of my... playlists. This would probably have been under game design. Yes, this one. Let's re-watch this and then see where...
There is a concept called intraditional vector animation.
So this was an interesting idea that I liked, and one of the reasons that I like it for this game specifically is that because we're fucking with time and the player might or might not be pausing it to do shit, I like the idea of being able to tweak the animation speed and the characteristics based around the time interval that we establish. So like if we expect between this turn and the next turn, if we expect it to take 5 seconds of real time, being able to tweak those animations for 5 seconds versus being able to tweak those animations for 1 second is, I think, a really interesting idea, and I really like that approach of an idea.
There is a concept,
as opposed to like messing with playback speed and potentially getting really weird artifacts because the force doesn't look right for the given speed,
called interpolation curves, which describes the way we move between one animation keyframe and the next. Depending on the shape of this curve, we can control motion to slowly ease in, to slowly ease out, or even to anticipate and overshoot the keyframe. The choice of animation curves can greatly affect the feeling of inertia and energy in the motion. This grants the animator
Okay, this is Blender,
a good
and he has an animation
deal
thing
of
on
artistic
something.
expression in describing motion while keeping the number of keyframes economical. In procedural animation, however, it can be very powerful to do away with the concept of keyframes entirely, freeing the system to move however the situation demands. This adaptability is one of the main reasons to incorporate procedural animation in games. For example, in the game I'm working on, I have this little robot character, which moves its body and legs using inverse kinematics in response to real-time requests to move and change orientation. I'm controlling it with my mouse here, and you can find tutorials for how to implement this sort of thing online. In-game, this same flexibility allows the character to immediately respond to changing gameplay situations. This is pretty nice, but because we don't have keyframes for these inputs, we can't really use interpolation curves to add that sense of inertia. What we'd really like is the ability to achieve something like this, using an intuitive abstraction similar to interpolation curves, but without losing out on the dynamic responsiveness of a keyframe-free system. Let's start off by describing the problem we want to solve a bit more precisely. Given some dynamically changing input x from our game world, we want to produce some dynamic output y, which tracks the input x, but is imbued with some sort of characteristic that conveys the way that we want the motion to feel. In the simplest case, y equals x, and our system rigidly conforms to whatever input we give it.
Right.
This isn't very useful on its own, but it is a good starting point. Whatever changes we make to this equation, we'll want to ensure that in the long term, when x isn't changing, y should eventually settle at x. To introduce the possibility for interesting dynamics, let's add some velocity and acceleration terms, represented here as first and second order derivatives with respect to time, scaled by some values, k1, k2, and k3.
I'm sorry, hold on.
The dot note. Whatever changes we make to this equation, we'll want to ensure that in the long term, when x isn't changing, y should eventually settle at x.
Right.
To introduce the possibility for interesting dynamics, let's add some velocity and acceleration terms, represented here as first and second order derivatives with respect to time, scaled by some values, k1, k2, and k3. The dot notation here is just a shorthand way of writing time derivatives, which you may have also seen written like this, or this.
Okay.
This type of relationship involving up to a second-order time derivative is known as a second-order system. Mechanical motions in the real world tend to be second-order, which you can think of as being related to the fact that forces act on acceleration, the second derivative of position, as described by Newton's second law. These forces usually arise out of stiffness, where they are a function of displacement, or out of friction, where they are a function of velocity, hence our choice of terms. For example, this is the equation of motion of a rigid body being dragged along one axis through a linear damped spring. And this is the equation of motion for the smooth damp function in Unity. By playing around with these values, k1, k2, and k3, we can generate a whole host of different interesting behaviors, but as an artist, it might not be very intuitive how these values map to those different behaviors. First, let's simplify the visualization to look at the response to a single sudden change in the input. The resulting output is known as the step response, which is a standard way of visualizing the dynamics of a system and captures the essence of the system's behavior. Next, using k1, k2, and k3, we'll define three new variables, f, zeta, and r. We'll use f, zeta, and r, which I'll explain in a moment, as the design parameters for the system's motion. Under the hood, we can use them to compute k1, k2, and k3. In this new parameterization of f, zeta, and r, each term controls something that we can develop some reasonable intuition about. F is the natural frequency of the system measured in hertz, or cycles per second. It describes the speed at which the system will respond to changes in the input, as well as the frequency the system will tend to vibrate at, but does not affect the shape of the resulting motion. Zeta is known as the damping coefficient. It describes how the system comes to settle at the target. When zeta is 0, vibration never dies down, and the system is undamped. Between values of 0 and 1, the system is underdamped and will vibrate more or less depending on the magnitude of zeta. When zeta is greater than 1, the system will not vibrate, and instead slowly settle toward the target x depending on the magnitude of zeta. The smooth damp function in Unity uses a zeta equal to exactly 1, which is known as critical damping. R is a value which controls the initial response of the system. When R is 0, the system takes time to begin accelerating from rest. When R is positive, the system reacts immediately to movement in x. When R is greater than 1, the system will overshoot the target. When R is negative, the system will anticipate the motion. When modeling a mechanical connection, a value of 2 for R is typical. Now, as artists, we have all we need to start playing with the characteristics of the motion of our procedurally animated object. The system reacts time to begin accelerating from rest. When R is positive, the system reacts immediately to movement in x. When R is greater than 1, the system will overshoot the target. When R is negative, the system will anticipate the motion. When modeling a mechanical connection, a value of 2 for R is typical. Now, as artists, we have all we need to start playing with the characteristics of the motion of our procedurally animated object. If we want to control the settling behavior of the system, we can play with zeta. If we want to control the initial response of the system, we can play with R. If we want to control how fast or slowly the system behaves, we can play with F. Coming back to this robot character, you can see I used an underdamped movement for the body, with a zeta of 0.5 and R of -2, to give it some anticipation before fast movements. For a bit of extra flavor, I tilt the body towards the target position to further hint at the intent behind the motion. I want the turning to be smooth, so for the body orientation, I use a zeta of 1 and R of 0. I do the same for the head orientation, but with a smaller f, to make it lag behind the body as a sort of secondary motion. The cables are animated with
What is the... I just realized. What is the name on this stream? Let me make sure I actually change that properly. Okay, it is Visual System. Okay, we're fine. I thought, I'm like, wait, did I ever update that? Okay, we're good.
A little trick that as a sort of secondary motion. The cables are animated with a little trick that I explained over on Twitter a while ago. Let's now look at an approach for solving this equation in real time so that we can begin using it in practice. There are many ways of numerically solving differential equations, such as our second order one, but a particularly straightforward one is called Euler's method. Today I will present a slight variation known as the semi-implicit Euler method, which, for our system, happens to have the same accuracy as the more complex Verlet integration. First, we need to allocate some state variables, position and velocity. These are our estimates of y and its first derivative. At time step 0, they need to be initialized to some initial values. Now, when the game is running, we'll want to iteratively update these variables each frame. Let's call the amount of time that passes between frames t. First, we update the position estimate by taking the previous iteration's position and adding t times the velocity. Next, we update the velocity by taking the previous iteration's velocity and adding t times the acceleration. To compute this acceleration, recall our equation of motion. We can solve for acceleration here and substitute in our most recent estimates of position and velocity. Note that in semi-implicit Euler, we are using the updated position to compute velocity, which is slightly different from the regular Euler method, where we use the previous frame's position. In the case that the input velocity x dot is unknown, we can also estimate it using historical measurements, for example, by approximating it as the average velocity since the previous sample. This algorithm naturally translates almost line by line into code.
Public class, second order dynamics, private vector xp, private vector y, yd, public float k1, k2, k3, float f, float z, float r. K1 is equal to z divided by pi times f. Okay, I might come back to this. 853 is the screenshot.
If we were to implement this in-game, we would see that it does work as designed. I hooked up the code to allow for f, zeta, and r to be changed in real time, and the system responds appropriately. There is one big issue that we'll run into after a bit of experimentation though. Set the resonant frequency f too high relative to the frame rate, and the system becomes completely unstable, launching itself to infinity. While it's possible to simply keep f low enough such that this type of glitch is unlikely, in a game engine, we would really like to have a stronger guarantee that something like this doesn't happen in corner cases, such as a lag spike causing the time step to be much larger than anticipated. This is a problem that can be solved, but to understand it properly, we'll have to get a bit more technical with our analysis.
Okay, let's go back to implementation. I want to rewatch this, make sure I understand this.
Let's now look at an approach for solving this equation in real time so that we can begin using it in practice. There are many ways of numerically solving differential equations, such as our second-order one, but a particularly straightforward one is called Euler's method. Today, I will present a slight variation known as the semi-implicit Euler method, which, for our system, happens to have the same accuracy as the more complex Verlet integration. First, we need to allocate some state variables, position and velocity. These are our estimates of y and its first derivative. At time step 0, they need to be initialized to some initial values. Now, when the game is running, we'll want to iteratively update these variables each frame. Let's call the amount of time that passes between frames t. First, we update the position estimate by taking the previous iteration's position and adding t times the velocity.
Yeah.
Next, we update the velocity by taking the previous iteration's velocity and adding t times the acceleration.
Sure.
To compute this acceleration, recall our equation of motion. We can solve for acceleration here and substitute in our most recent estimates of position and velocity. Note that in semi-implicit Euler, we are using the updated position to compute velocity, which is slightly different from the regular Euler method, where we use the previous frame's position. In the case that the input velocity x dot is unknown, we can also estimate it using historical measurements, for example, by approximating it as the average velocity since the previous sample. This algorithm naturally translates almost line by line into code.
You know what this kind of looks like? This kind of looks like a fucking job. Okay, we can use the job system for this. So what I'm thinking is, if we do implement this idea, we hook this up to a job that runs every frame on the visual system, and then we have some set of tracking info for what you'd expect the animations to be at that given at the end result, I think. So yeah, I think we could make this a job where this is a function that creates the initial struct data, and then we modify it with we override it with this, and then we iterate over the agent with that information every frame. I'm trying to imagine how you would do a more complex animation. Like, if you're trying to do a humanoid, you have to make sure that, like, I don't know. I guess if you kept it... I was wondering recently about what art style I was going to go for with the kind of overall aesthetic, and I was thinking about doing low poly. One, because you can make it look good relatively, not as hard as like a high quality look, but two, it's just easier. And my ass is fucking dog shit at art, and I don't have money to buy an artist. So I'm thinking about doing low poly and doing like a low poly kind of horror vibe. I think that would work out pretty well, and then I can just make the textures and shit look really good on top of it. As kind of like a stylized, I don't know if juxtaposition is necessarily the word, but I don't know, you could see, but I think that's what I want to go for. And I feel like it also kind of helps the fact that it's like a grid map to have like low poly art. I feel like that would work really well with that. So in my head, low poly would work better with this kind of system as opposed to like a more complex animation state, because with like a realistic human, you would need to like make sure that everything looks right in order to sell that feeling of believability. But if you just make the animations, even the animations are kind of janky, although I'd like the animations to be very smooth for this game, but even if they were, it would still kind of fit that poly vibe as opposed to like a more normal model. Yeah, okay. So yeah, I think I keep this function in mind. I think I get this. So you would make... This would be your... The way this would work is you'd have a struct that stores this information. Maybe even per joint. I'm not sure. You might have to make... you might have to split or you might have to take like a skeleton of like a humanoid and assign each point on the model. Maybe you still have to rig it, right? And you assign each rig bone its own struct information, and then you start adjusting it that way. But I also don't know how you do like rotation and stuff, because this is just for movement. The rotation is like, I'm trying to think, if I did like a kick, right? You're gonna raise your hip and you're also gonna kind of like twist. And so I'm trying to imagine how you would do that without it looking really janky.
If we were to implement this in-game, we would see that it does work as designed. I hooked up the code to allow for F, Zeta, and R to be changed in real time, and the system responds appropriately. There is one big issue that we'll run into after completely unstable is unlikely, causing the times technical. There are feedback systems whose outputs... The reason why physics solvers, like Euler's method, can become unstable is that fundamentally, there are feedback systems whose outputs from one iteration, here y and its derivative, are fed back into later iterations of the computation.
Right.
When the time step between frames is too large compared to the parameters, it will start accumulating errors over time. Beyond a critical threshold, these errors will start to compound on themselves, quickly leading to catastrophic failure.
Sure.
To compute this threshold, we'll need to organize the problem into a more standard form. What we want to do is write the values of our state variables at frame n+1 in terms of our state variables at frame n. We can do this by substituting the first equation into the second, so now both our equations have y and its derivative at frame n on the right-hand side. Now let's expand this and collect like terms. This is a system of linear equations, which we can write in matrix notation. The system, written this way, is known as the state space representation. This matrix A, known as the state transition matrix, describes how each iteration of the state variables influences the next iteration. Intuitively, you can imagine that the feedback will be stable if A doesn't cause the state variables to grow. If A was a number instead of a matrix, it would be easier to reason about the effects that it has on the system. For example, in this simpler system with only a single state variable and no external forces, each iteration is equal to the previous iteration scaled by A. When the magnitude of A is less than 1, the magnitude of y at each iteration will be smaller than the previous iteration, causing the system to stabilize over time. When the magnitude of A is greater than 1, the magnitude of y at each iteration will be larger than the previous iteration, so the system will quickly grow beyond control. This is what we'd like to avoid. In our system, A is a 2x2 matrix, which doesn't have a magnitude that can directly be compared to 1. Instead, it has what we can think of as two separate magnitudes, called eigenvalues. We won't get into it here, but suffice to say that both of these eigenvalues, z1 and z2, which are computed by finding the two solutions to this equation, must have a magnitude less than 1 for the system to settle over time. This is computed like this, which expands to this quadratic polynomial of z, which we can solve using the quadratic formula. Our system will be stable when the magnitude of this expression is less than 1. Solving this inequality gives us the following constraint, that the time step t must be less than the square root of 4 times k2 plus k1 squared, subtract k1. In our code, we can compute this maximum stable time step, t critical, and when running in-game, compare the time step against it. If the time step is too large, we can divide it up into smaller steps that are below the stability threshold. Taking smaller steps requires performing more computations per frame. To avoid this, we might be able to get away with slowing down the dynamics instead. In this case, rather than constraining t, we can solve for k2 and constrain that. Clamping k2 to be above this value is not physically correct, but recall that our goal here was just to prevent catastrophic failure, not to produce an accurate physics simulation. There are, of course, much more esoteric places you can take this analysis, and in a previous draft of this video, I did go a bit further. For example, this frame-to-frame jittering behavior that sneaks in when the frequency is sufficiently high is caused by negative eigenvalues, so if we also take that into account during our analysis, we can impose additional restrictions to ensure it doesn't happen. In my own implementation, in case accuracy is needed, I opt to use a method known as pole zero matching to compute values for k1 and k2 per frame based on the time step. This produces generally more accurate results for very fast movement, but comes with this additional computation cost that might not suit every application. The idea behind using simple parametric motion models like our f, zeta, r1 extends some interesting possibilities. Just as an example, we could modulate the values of these parameters to convey gameplay information, so characters can move with different parameters depending on their state of awareness, health, status effects, and so on.
His model is rotating.
This would help communicate the...
But I don't see in this code where the rotation is, because f is, r is like initial speed, z was, the like angle that you'd get at, and f is the frequency. So I'm trying to imagine how you would modify the rotation for this as well.
The idea behind using simple parametric motion models like our f, zeta, r1 extends some interesting possibilities. Just as an example, we could modulate the values of these parameters to convey gameplay information, so characters can move with different parameters depending on their state of awareness, health, status effects, and so on. This would help communicate the situation to players through motion in a way that's cheap and easy to iterate on. In any case, I've spent long enough working on this video instead of my game, so hopefully this has been an approachable but substantial introduction to some interesting concepts, or maybe a presentation of some applications of mathematics in an unusual but interesting context. As always, thanks for watching.
So this was the final code.
Further. For example, this frame-to-frame jittering behavior that's our analysis, we can impose additional restrictions to ensure it doesn't happen. In my own implementation, in case accuracy is needed, I opt to use a method known as pole zero matching to compute values for k1 and k2 per frame based on the time step. This produces generally more accurate results for very fast movement, but comes with this additional computation cost.
Okay. Procedural animation tutorial. Use inverse kinematics to control the leg. Fix bottom leg to the ground. Make a target point attached to the body. Raycast from the target point downward and move up and down. Okay. That seemed way simpler than than I thought it would be. Alright, let's see this video. Let's go down this rabbit hole. I'm ready.
Custom, contextual, and procedural animation are all features we've seen in big AAA titles that are now more possible than ever in Unity thanks to the animation rigging package. Today, let's start learning all about animation rigging, the animation rigging package, and how we can use it to add procedural animation to our games. And now, let's get started. A classic animation pipeline for Unity game development starts with modeling and texturing a character based on concept art and turnarounds using an external software like Blender. That model then undergoes two processes called rigging and weighting, which build out the skeleton of the model and determine how the model can and should deform.
Right.
The bones can then be moved, rotated, and keyframed to create new animations. When animations are complete, we can then take the ready-to-be-used character and animations into Unity. This is a tried and true pipeline that has gotten the job done for many years, and if we look at the vast majority of 3D games from the past up to more recent games, it's been used to create most animations. However, there are now a few additional animation options that shake up this pipeline, and the option that we will talk about today is procedural animation. Procedural animation is generated in real time. While standard animation saves the rotation and placement of the character's bones prior to the game running and uses those saved values when the game is being played, procedural animation is able to move bones based on what's happening in the moment and in the environment while the game is running. Now, the extent of how much procedural animation is used will vary between games and its use case. A game like Uncharted uses procedural animation for actions like characters reaching to touch a wall, foot placement, head and arm rotation, and a bunch of smaller details, whereas games like Fall Guys and Game Beasts are much more noticeably procedurally animated, as their character animation is almost entirely physics-based, which is a form of procedural animation. To be clear, procedural animation isn't exactly new to indie games, or even Unity for that matter. There are asset store packages that allow us to create procedural animation. Unity's Mechanim animation system has offered support for animation layers, animation blending, and inverse kinematics, which can create some similar effects to what we can do with the animation rigging package, and procedural animation can be programmed ourselves using code. So then, what does the animation rigging package actually offer? The answer is a helpful user interface in the Unity editor, a list of constraints that can be used to achieve multiple types of procedural animation, and dynamic rigs. And let's not forget to mention that we can access this package for the low price of free, and bugs have the possibility of being fixed by the Unity team themselves, which is always a benefit. All that sounds pretty good. Now, what exactly are constraints and what are rigs? Remember the animation rigging process mentioned earlier when describing the animation pipeline, building and connecting bones of a model which can then be used to animate the character. But to be more specific, rigging is more than that. It's not only adding the bones, but applying constraints between specific bones. Constraints will determine how bones can be moved and rotated by the animator, and sometimes what happens when the bones are moved. For example, a constraint may be placed on a hand so that when it moves, the arm and shoulder bones move as well, like they do in real life. And rigs are the collections of bones and constraints. A rig might consist of all of the bones and constraints of a model, sometimes referred to as an uber rig because it houses everything, or a rig can only focus on specific bones and constraints, just like a single arm. So now, let's get a little hands-on. In Unity, we can download the animation rigging package from the package manager. By using this package, we can essentially move part of the animation pipeline into Unity itself. Here we have Bananaman, an imported character asset from the asset store. The original bone layout and weighting for this character had to be originally done in an external software like Blender, and that is still the case despite the animation rigging package's new features. As mentioned, this package doesn't mean all of the animation pipeline is now in Unity, rather specific parts which will make procedural animation easier. But with those original steps of the animation pipeline already complete for this character, we can now use the animation rigging package to render the bones, create brand new keyframed animations, and of course, procedural animations using runtime rigs and constraints. Let's begin. The first step is to attach an animator component to the animated game object. In this case, our character game object, which has the armature as a child. The animation rigging package is built on top of Unity's mechanism animation system, so in order for it to work, the animator component is required. The animator component allows any game object to be animated, and when combined with
the and of this part at times 2 speed. I'm not following.
Of course, procedural animations using runtime rigs and constraints. Let's begin. The first step is to attach an animator component to the animated game object. In this case, our character game object, which has the armature as a child. The animation rigging package is built on top of Unity's mechanism animation system.
Animation rigging package, rig builder, rigs, constraints.
So in order for it to work, the animator component is required.
Okay.
The animator component allows any game object to be animated, and when combined with an animator controller, can be used to play animation assets in the animator window. The next required component is the rig builder. As we create new rigs for this animated game object, each will be added as a layer to this component's list property. Think of this as the controller for all of the rigs that might be added to a character. Each rig added to the list is to be ordered by priority, but the order must be decided before the game is played. The rig builder interacts with the animator component, which is why it must be added at the same level as the animator component, which again is the parent to the bone hierarchy. This next component is technically optional in the setup process, but will help tremendously with creating animations and working with the animated game object and character model. We are talking about the animation rigging package's bone renderer component, which we attach, again, to the parent game object of the bone hierarchy, same as the animator and rig builder. We can then select all of the bones in the hierarchy window and drag them into the transforms list. A known bug, but you may need to refresh the component for them to show up. Alternatively, if we select the parent game object, the animation rigging drop-down menu has a button that will set up the bone renderer automatically. The remaining properties of the bone renderer allow us to customize the appearance of the stored bones. We can select from 3 different options for the bone shape, increase or decrease the size, and customize the bone color. Enabling and modifying tripod size will display the local axes of each bone, making it clear how the bone is rotated. The bones are only visible in the scene view, which is where we would want to manipulate the bones anyway. But with it set up, we can more easily create and manipulate rigs. In the context of the animation rigging package, a rig, otherwise known as control rig, is a collection of constraint game objects and the possible source objects of the constraint. Source objects are what the constraint requires to be used properly. To create a rig, we just need to add a new game object as a child of the parent game object that holds the animator and rig builder, and then add the rig component. This is typically the same level as the bone hierarchy, so to be clear, rigs and constraint components are to be used outside of the bone hierarchy, not on the bones themselves. And we can now add this rig to the rig builder as its first layer.
Okay, so if I understand this correctly,
to give this rig,
you still do the rigging in like Blender or whatever, and then you import it in. It's just that once you import it in, then you put them underneath it as like just like a big hierarchy of game objects, I think.
Functionality, we create a new game object as a child of the rig for each constraint that we'd like to have. Let's add our first constraint. We will create a new child empty to the rig. Select the animation rigging option in the menu and choose from the list of constraints available. Each constraint has its own set of properties. Now, there are many to cover, and I believe we'll go over them all at some point on this channel, but if you'd like me to make a video of practical uses for each constraint or a specific one, be sure to leave a like and a comment below telling me which you are interested in. For today, let's start with the most basic example, by having the character's head turned towards its target. For a better naming convention, we'll rename the rig from rig to target tracking, and rename the child to head tracking. Then let's add the multi-aim constraint to head tracking. This constraint rotates the constrained object to the direction of a required target transform. Because we have used the rig renderer, we can much more easily select the head bone. But before we do, let me show you a quick Unity tip. We can right-click on a game object in the hierarchy and press on Properties to open a new inspector window that will never change targets. What this means is that if we are going to be working with a specific game object and its properties, we can now add it as a separate window in the editor. This allows us to much more easily select and drag a game object from the inspector into a property value without worrying about the inspector accidentally changing to the new game object from the hierarchy. Cool. Let's drag the head bone from the hierarchy into the open constrained object property. The only other required component for this constraint to impact our character is to add a source object, aka what we want it to look at. Let's create a new object titled Look at Target, and then drag it into the source object list. Moving around the source target, and we'll notice that nothing is happening. This is because constraints only work when the game is running, or when preview mode is active on the animation and timeline window. If we enter play mode, we can now see that if we move around the target, the head follows. You may be wondering what the remaining properties of the multi-aim constraint are for. They determine how the constraint rotation works. Note that other than wait, in order for the changes to take effect, we actually need to restart play mode. Weight is the percentage of influence we want to apply to the constrained object, 1 meaning 100%. The aim axis should be set to the specific axis that we want to point towards the target. For a character, this is most likely going to be Z in Unity. And setting the up axis will determine which axis we want to be rotated toward the upward direction. However, this doesn't do anything without the world up type set. Specifying the world up type will determine which direction the constraint will consider upwards and how the rotation handles rolling. Here is the difference between setting it correctly and not setting it at all. We've seen one source object, but we can also add many more. Playing with the weight slider will determine where the constrained object will rotate. Having multiple at a value of 1 will rotate towards the center point between the source objects. Maintain offset will keep the object in its original rotation until the source object is moved, but will then rotate to follow its movement path. Offset is simply an additional applied rotation to the object. Selecting X, Y, and or Z of the constrained axes property determines which axis is allowed to rotate in order to look at the target. And min and max limits determine how much rotation can be applied to any of the available axes. For a character, we're looking at about -90 and 90 for the min and max values. And that is working procedurally generated head tracking. Part of the beauty of how the rigging package is designed comes from the rig builder and its layers. We can have separate rigs for different situations that the animated game object or character may encounter and activate and deactivate each layer accordingly. We can have a target tracking rig, which has a constraint for the character's head. But we can also have completely separate rigs for things like climbing, which has constraints for the hands and legs to properly position themselves on a wall, or passive interactions, which could have constraints that handle interacting with the environment. The point is, the layout provided to us as developers is super flexible. In the future, we'll take a look at more practical uses of each constraint, discuss some of the limitations of them.
Okay. That seems promising. Let me turn back onto this. There we go. Well, ID isn't equals. I don't know why I'm reading this. Okay, so I want to try the procedural. I think it'd be interesting. I think it'd be a fun challenge. If I end up hating it, then we can always swap to the make a million animations and make me want to die inside method. So... Okay, let's go back to what our to-do list was. I'm losing it. Tie actions to visuals. Right. That's what we were supposed to be doing. That's right. And then we were trying to figure out how we were going to properly connect everything, and then and then we ended up with the animations. So I think if we do animations that way, I think what we'll end up with, or if we do it anyway, to be honest, either way, there's going to be a collection somewhere of the relevant animation data, whether it's going to be like which procedural points it needs to move towards, or whether it's going to be, you know, what's the keyframe that it's going to launch into. And that'll have to be ID'd somehow. And so we're going to read that ID, or we're going to do this. So I think what we'll do, I don't know why I'm in visual mode, is either way, let's make a new public struct called animation action animation. We'll call it action animation. Yeah, we'll make it an I component. Nope, wrong one. This one. And then we're going to make a public, let's do a byte ID, and we'll just make, there's very, very, very little chance that we'll need more than 255 of these per unit. I would be very unhappy if we ended up in that world. So we'll make it an ID, and then all we're going to do is up here, we're gonna make a collection, that's going to be we're gonna have each archetype hold that information in here, or are we going to do that back here? I think the best way would be to have each... I don't like the idea of putting the animation data in here. So instead, it'll probably need to be a similar collection to the actions one, which is a list of a list. And do it that way. So let's just tie... Let's do it here. Let's be smart about this. Make an unsafe list, and we'll make it an unsafe list of type action animation, and we'll call this yep, action animations. Perfect. And then we're going to go over to here. Dumbass, not Control S, Control W, and we're going to okay, so while the animations is greater than 0, we're going to make a new function down here. Well, no, here's how we're going to do this. We're going to make a queue. Let's hop back over. Whoa, what did I hit? Control. Cancel. Control. Oh, I did Alt instead of Control. That was the issue. Okay, still learning this keyboard. we're gonna make a public unsafe queue of what would you call this? This is going to be a queue of the actions to complete this cycle. So it's similar to, or animations to complete this cycle, or current animations. So what it's probably going to be is it's going to be action animation, and we're going to name this current queued animations, and then we're going to delete that. We're going to there. Okay, and so what we're going to do is we're going to go back into here, and we're going to say, basically the reason for this is that even though we're not doing the turns simultaneously, we are doing the animations simultaneously. And we don't want, even though we're doing all of the turns in buckets, we want to still make sure that the animations that are supposed to happen right now happen. So the best way to do that is we bucket out which animations are supposed to occur. Like let's imagine that there is 3 time slots worth of potential turns to take. 2 enemies are going in the first, 4 enemies are going in the second, 5 enemies are going in the third. We want to take the first 2, start their animations, then take the 4, start their animations, take the 5, start their animations. So we queue the first 2, then we do the first 2 either procedurally or whatever, wait for those to finish. The frame that those are about to be done, we start the next 4, and then the next 5, and then we wrap. So what we probably want to do is we're going to, the nice thing I think about this turn system, which I'm going to rely on right now, and maybe we have to come with a smarter system in the future, is at some point, if an enemy gets done twice in a queue, that means that we've gone all the way back around to them. So all we have to do is take the queue of actions, and we need to check to see who started this cycle, and then iterate through until we have queued it. So all we're going to do is we're going to go into I guess we can make it an array, because it doesn't need to be popped one after the other. It needs to be popped together. So let's make an unsafe list. Okay, and then we'll hop back, and then we're going to say if no, we're gonna, up here we're gonna say byte starting enemy is equal to Do we make it a... I guess if we make it a list, we'd have to constantly resize it, which I guess is fine. The main reason I think I'm okay with it being a list is because we can then just do a quick iterate over in the job entity when we're playing out the animation data. And if we have like a procedural system, then we just modify the procedural data like in just in each entity parallelized, which won't be too bad. I just had a thought, and I'm worried I broke something, but I'm thinking through. I think we're okay, so I won't say anything about it, but then we'll be fine. So what we'll do is we'll say, I think we do make this a for loop. I wasn't going to originally, but I think we do make this a for loop, so we can use the. Then we'll do and I is equal to 0, I is less than and then we'll say okay. Oh, I'm probably gonna have to make that a hash map actually. Whoa, why are you not? What the fuck is happening? Why is moving getting me stuck inside this? What the fuck is happening? Control Z, Control Z. Oh, caps lock is fucking on. That's why. God damn it. Okay. And save hash map. Okay. And that's gonna be a byte. So the way this will work now. Nope. Undo. There you go. The way this will work now, and then we're gonna bracket this into I need to stop doing that. No, BSD. I'm gonna lose it. Dot there. Jesus Christ. So yeah, what we're going to do is we're going to, that action animations is going to be a list of every archetype, and then, oh, I need to make this up. Archetype check. And we're going to reference this twice, so I'm actually going to probably put this here. Action args AG is equal to BSD dot actions through the cycle dot DQ. Why did the curly bracelet come over here? And then we're going to go here. We're going to do BSD dot archetypes. Christ, I don't know why I did that. That action. Oh, because caps lock is on again. What the fuck? Okay. Yeah, so we're going to grab the agent ID, and then we're going to take that and take the action ID. Okay, yeah, so we're going to have a list of all the archetype, and then it's going to have a hash map of the action to the animation. And then we're going to grab the animation of that action, and we're going to add it to our queue. And that's going to DQ it, and that'll do the check. Possible problem here. Yeah, so the problem is we don't want to increment. Can I do plus equals 0? Or just not write it? Okay. Yeah, I'll do that. Perfect. So it's going to DQ it, then it's going to check that, and then if, we're going to go down here, nope. If action args, no, if ag dot agent ID and then this will be run queued animations, and then once the, or no, it'll be begin running queued animations. I guess we can make it a background task and then just do a job handle check to see if it's done. And then when it's done, we recheck to see if it's greater than 0, and otherwise we pass out basically to the next section. Okay. I am going to do something. I don't know what I'm going to do. I need to think about this, and I feel so dumb just sitting here, like, racking my brain about trying to make sure I structure it right moving forward, like, on stream, because I feel like it's so much easier to focus on it when I'm not on stream, and I feel like I'm just wasting everybody's time if I do it on stream. So I'm going to just get off stream for a bit, probably play a game or something, or work on something, and maybe start working on some models and kind of just think this through, because I think what it's going to have to be, I think what it'll end up being, is that I'm going to have a collection of animations, which are probably going to be like procedural waypoints or something, and maybe like potential particle effects that get played at particular time sinks. And then we're going to run I'm blanking. Then we're going to basically queue them up and then start playing them, pause out the visual system until it's done, and then keep doing that, and then go back to the behavior system to check for the next stage, and go back and forth until we'll probably do all the behavior, then all the visuals, and then run the player, and then do it all over again, would be my thought. So we'll see how that goes. And then maybe I'll do it on stream or not. I would need to go through and actually like set up the camera and like start changing the world tile positions and stuff like that to make it look closer to what I have in my head. But I don't know. We'll see. Either way, I'm gonna see if I can get this fucking OBS stuck out of the ceiling. Get this computer a bit more set up. So I'll see you guys around. Thanks for hanging out. Thank you for watching the stream, because I know the stream's boring as fuck, and maybe I'll